Okay, this is lesson 4.2. It's a standard form of a quadratic function, and we're going to learn how to graph quadratic functions written in standard form. The standard form for a quadratic function looks like this. F of x equals ax squared plus bx plus c, and a is not equal to 0. If a were to be equal to 0, then you would only have a linear function because you'd have something in the form of like bx plus c. So we need to have that x squared term to make it quadratic. Problem 1 says, what are the vertex, axis of symmetry, maximum or minimum value, and range of that equation? And so what I'm going to do here is we're going to find our vertex. And how you do that is you first use the equation x equals negative b over 2a. That's going to give us our axis of symmetry. So if you recall, because of standard form, our a in this case is going to equal negative 1 because we have a negative 1x squared. Our b is 6 and our c is 3. So if I were to substitute in to this, I would get negative 6 over 2 times a negative 1. So I get an axis of symmetry of 3. X equals 3. That's our axis of symmetry. Now, once you have found your axis of symmetry, you're going to use that value as your x-coordinate of your vertex. So now I'm going to find my vertex. And what I'm going to do then is just substitute that 3 back into x here to find the y value. So I'm going to get negative 3 squared plus 6 times 3 plus 3, and that's going to equal y. And when you do that, then you end up with, what do we get? We get negative 9 plus 18 plus 3. That would be 9 plus 3 is 12. So I get a vertex of 3, 12. So what are the vertex? What are the axis of symmetry? And then we're looking at the maximum or minimum value and the range of the function. So we have to do all of that. Let's graph what we have so far. So if I plot the point 3, 12, we're going to go off of our graph here a little bit. It'll be 1, 2, 3, and then you go 1, 2, 3, 4, 5, 6, 7, 8. So let's actually go by 2's on this y-axis. So 2, 4, 6, 8, 10, and then we'd have 12. So if I plot the ordered pair 3, 12, I'm right here. I know my graph is opening down because my leading coefficient is negative 1. What I like to do now, we can use the y-intercept 0c as another point. So I'm going to put in 0, 3. We'll plot that. That's going to go right between 2 and 4 there. And then because of symmetry, I also know I have the ordered pair 6, 3. So we'll go out to 6, 3, and then I can draw in my curve. So there's my parabola, my U-shape opening down. Again, the axis of symmetry, x equals 3. You use this formula to find that. Here is your vertex. I know my x of my vertex. It's the value I got for the axis of symmetry. I plug it in to find my y, and then I need to plot at least one other point and its reflected point to draw in the curve. So this point here, I'm going to have a maximum. My maximum, because it opens up, is going to be the value y equals 12. That's the highest point my graph is ever going to reach, and that also helps define the range. If I look at my graph here, all of my y values will be less than or equal to 12 because it's opening down. So the range of this is y less than or equal to 12. Your range will always tie in to your maximum or minimum value. Okay, so now for new concepts again, the quadratic function in standard form, we talked about that. I'll write it back down again here so we can refer to it. It's f of x equals ax squared plus bx plus c. You're going in descending order by your exponent, and then a is not equal to 0. The graph is a parabola. The a value is, if a is greater than 0, your graph will open up. If a is less than 0, your graph opens down. So that helps you know if you have a U-shaped open up or open down. The axis of symmetry, we use this equation, x equals negative b over 2a. And the vertex then, you take that value, negative b over 2a, that's your x-coordinate, and then substitute whatever that is into your equation to find your y. So evaluate function for x equals the negative b over 2a value, and then you'll know what your y-coordinate is for that. And then your y-intercept is always the ordered pair 0, c. If I were to replace x with 0 here, I would just be left with c. So you have your y-intercept. So let's look at problem 2. It's asking us to graph this. So here we go. We're going to do x equals negative b over 2a. That's, once it's in standard form, I go straight to that. My a is 4. My b is negative 16. And my c is 10. So if I substitute, the opposite of b will be 16 over 2 times 4. So I get 16 over 8, which is 2. So my axis of symmetry is x equals 2. If I fold it along that line, it'll all match up. Now we're going to find our vertex. So I know it has to be 2 something. To find what that something is, we're going to go and put 2 in for our x in the original equation. So I have 4 times 2 squared minus 16 times 2 plus 10. So 4 times 4 here is 16. Make sure you square the 2 first and then multiply by 4. Minus 32 plus 10, that will give us a value of negative 6. So our vertex is 2, negative 6. So we can plot that right away. So I'm going to plot 2, negative 6 here. Again, the axis of symmetry, you can draw it in if you want. You don't need to. If I fold it along that dashed line, it's going to match up. The other thing I know is it has a y-intercept from what we know here of the ordered pair 0, 10. Now 0, 10 is kind of hard to plot. It's going to be off my graph here a little bit. You know, you could go up here and kind of guesstimate it's going to be up here somewhere. So I know it's a really kind of narrow type of parabola opening up. What you could also do to get another point is literally just create a table of values and like evaluate it for x as 1. So if I put 1 in for x here, I would get 4 minus 16 plus 10. That's what? Negative 12 plus 10, I get negative 2. If I have that one and I can plot that easily on my graph, then I can do the symmetrical point on the other side, and then I can draw in my parabola opening up. When you're drawing in your parabola, put arrows on the ends because it keeps going. The graph does not stop there. So again, we started with that to find our vertex. The vertex is huge. You have to plot the vertex. Okay, so problem C3, says, what is the vertex form of that equation? And remember what vertex form looks like. It's y equals a, x minus h, the quantity squared, plus k. And hk is our vertex. So if I can find my vertex, I can substitute it in for hk, and we're really close then. So let's start with our vertex again, and to do that, we're going to use this equation, x equals negative b over 2a. A is 2 in this case, b is negative 3, and c is 2. So I get x equals the opposite of negative 3, which is 3 over 2 times 2. So I'm going to get an x value of 3/4, which is my h value, right? And then now we need to come up with our k, or our y value of our vertex. We're going to have 3/4 something. So put the 3/4 again in for x and evaluate that. So 2 times 3/4 squared minus 3 times 3/4 plus 2. That's 2 times 9/16. 3/4 times 3/4 is 9/16. Minus 9/4 plus 2. And when you clean that whole thing up, you're going to end up with 7/8. Hopefully you're okay adding and subtracting fractions. Remember, you need a common denominator. Your calculator can do that cleanup work for you too. So I get a vertex of 3/4, 7/8. So now I know what my h and my k are. And guess what? The other thing we have to substitute for is our a, but we already know our a. So we don't even have to do anything fancy for that. So my final answer is going to be y equals 2, x minus 3/4, the quantity squared, plus 7/8. That's vertex form. If I were doing this on a test and I wanted to make sure I had the right equation, I would put this into maybe my y sub 1 on my calculator and put that in my y sub 2, and when you graph them, the graphs better match because they're equivalent equations, so they should match perfectly. If they don't match, something's funky. You better go back and double check your math. Problem 4, a model for the performance of a stock is P equals negative 3D squared plus 50D, where D represents the days of trading and P is the price per share. What is the maximum price per share of the stock? Whenever you see max or min, you need to find your vertex, because what we're looking for is our Y value. Okay, this is a parabola opening down, so it's going to have a shape like this. It's this point here I'm interested in. I need to know how high up, what's the maximum value. That's my Y value of my vertex. That's what I'm looking for. So we're going to first start with negative b over 2a, because we need that then to plug it in to find our Y. So our b in this case is negative 50. Our a is negative 3. As I clean that up, I'm going to get 50 over 6. Which cleans up to 25/3. So that's our x value, but it's not asking for that. It's asking for really our y value. So now take this 25/3 and put it in for D and evaluate your price. So P equals negative 3 times 25/3 squared plus 50 times 25/3. And when you do that math, it's going to be approximately, I should put approximate, not equal, because it isn't equal exactly. It's approximately $208.33. So that would be the Y value, 208.33, and that is your answer. What is the maximum price? Right there, $208.33. We're not going to have a price any higher than that. So that was lesson 4.2. What we were able to do is we were able to graph quadratic functions written in standard form. Again, you have to start right at the beginning with x equals negative b over 2a, and the rest of it should fall out for you. Good luck.